This is not to scale, in its orbit. And we have NASA scientist Troy Klein as the Earth, as the sun. Well, as the moon orbits, it can come in its orbit directly between the Earth and the sun, blocking our view of the sun, casting a shadow on the Earth, and making a total solar eclipse.
Okay, Paul. I happen to know that that moon goes around the Earth every 28 days. So why is it that we don't get an eclipse every month?
Well, it turns out the moon's orbit is actually tilted about 5 degrees, about 10 lunar angular diameters, so that in last December, when I set this up to represent, the moon passes quite a ways above the Earth-Sun line,
right,
and the shadow misses.
I see. So it's March now. How come we're getting an eclipse?
Well, let's go from December here to March.
Okay.
So we'll let the Earth orbit.
The Earth is
around.
orbiting 3 months
And
into the future.
That's right. Here we are in March in Woolly Eye. And the moon's orbit has remained in its same orientation. So that now, when the moon goes around in its orbit, as it crosses the plane of the Earth's orbit, it blocks the sun. So now we can have that total solar eclipse in March.
Gotcha. And I guess if I think about that, I know that the Earth goes all the way around the sun in a year, so there might be another chance for an eclipse.
Right, in 6 months, we'll be on the exact other side of the sun, and the moon would pass through the plane, perhaps at the right time. The timing has to be right to actually make a total solar eclipse.
Gotcha. So there's sort of 2 chances to see an eclipse every year.
There's 2 solar eclipse seasons per year, and we don't have a total solar eclipse every season. The timing has to be right.
Okay, I hear some cheering in the crowd, which makes me think we should check out the telescopes. So let's take a look. Okay, so I'm seeing a little bit of cloud cover. So I guess that's what they were sighing about, is we have some clouds, so our telescopes have gone dark. When I look up overhead, I do indeed see a big black cloud, but I also see blue off into the distance. So I have a feeling that, I don't know, you want to call that, Paul, 10, 15 minutes, we'll get blue skies again?
The clouds are moving really quickly. I think it'll be sooner than that
All
when
right.
we'll get our view back.
Well, that sounds awesome. In the meantime, let's talk about what else is going on. So I get that from here, when I look up in the sky, the moon is blocking my view. But if I was in space and looking down at the Earth, I'd see something different.
Right, we have a video to show you, which we show the moon in this animation moving between the sun and the Earth. In this animation, we let you see the shadow of the moon, which you'd never see in the vacuum of space. And you can see how it tapers down to hit a spot on the Earth where we'll be standing.
I see, so there's that big shadow, and it's actually moving. You know, it's strange to think about the moon casting a shadow on the Earth. I wonder what that would look like.
Well, if we back up into space,
Yeah.
for the eclipse of 2006 over Africa, here's a photo from a spacecraft, and you can see the shadow of the moon in the Sahara Desert.
Wow, it's actually smaller than I would imagine.
Oh yeah, in fact, the darkest part, the totality, is always less than 107 miles across.
Oh, very cool. So let's talk a little bit about why we're here in Woolly Eye today. So the Earth is getting a shadow cast on it from the moon.
That's right. And the Earth is rotating, and the moon is moving in its orbit. And that combination of motions leads to the shadows sweeping across on the path of totality. And here we see partial eclipses. These lines represent partial eclipses. But then the red band is total solar eclipse sweeping across Borneo, Indonesia, heading up towards us in Woolly Eye Atoll.
So you need to be in that red line to get totality.
That's correct. That's correct.
Okay.
And here it is sweeping across Woolly Eye and
Yay.
on across the Pacific.
That's where we are. So if you notice on this path, a lot of that path of totality is on water. And we need actually firm ground in order for our telescopes to send back the best images. So that sort of talks about why we're here in Woolly Eye.
That's right. And in fact, these bands on either side represent the degree of partial solar eclipse you can see. So you can see that from the Philippines down to Australia, people are seeing partial solar eclipses.
Right. And here today we're not quite seeing anything yet, but very soon. But I'd like to talk about the journey to get here. Woolly Eye is an awfully remote place. So our crew actually spent 22 hours. It was a 3-airplane journey to get here until we arrived in Yap. Colonia is the capital of Yap, where we boarded a liveaboard boat called the Solitude 1. We spent about 2 days crossing the open ocean, and it was pretty bumpy. We got a little bit green until we got here to the Woolly Atoll. Our first thing that we needed to do was to come ashore and sort of scout around. Where was the best place for us to put our telescopes, our satellite dish, where we get the best images? And we picked the runway. It's an old World War II runway. And then the next step, of course, was bringing all of that gear onto shore. We actually have about 56 cases of gear, about 2 tons. We need to bring it here to the runway, unpack it all, get it set up. We had cameras to set up. We had a lot of cords to plug in. The satellite people had to tune the satellite and make sure that they could hit the bird up in the sky. We had telescopes to get into place. Bill spent a lot of time aligning those telescopes, night after night after night. But we finally had it all worked out. We had everything sort of in place, which then for the next few days gave us an opportunity to sort of rehearse this, to think about what we wanted to do. But it also gave us an opportunity to spend a little bit more time checking out the Woolly Atoll. It's an incredibly, incredibly beautiful spot. A beautiful blue lagoon, palm trees and breadfruit trees. The people here live quite a traditional lifestyle. They live in traditional longhouses. And here I'd say these are some of the chiefs. There's 2 chiefs here on the Woolly Atoll. We met with them. We formally asked permission to be here. They were so kind and so welcoming. They offered to host us and give us whatever support we needed. The local folks, too, were so gracious. They offered us coconuts to keep us hydrated. They offered us food. I spent a little time in the women's longhouse as they were preparing food, again, mostly taro and breadfruit. We wrapped them up in leaves, banana leaves. I asked the ladies why they were making so much food. There were just piles and piles, big baskets of food. And they said it was because, as their tradition says, they needed to feed everyone who's coming here. And we have quite a few eclipse chasers on the island with us. People from all over the world have come here to witness the eclipse, as well as a lot of people from the outer islands. What you're seeing now is some of the weaving. You'll notice when you get here, everything's woven. Side panels of the longhouses, baskets. It's a beautiful place.
It really is. And we taught the students here how to observe the eclipse safely, what to look for during totality. They were amazing. They were really interested. We gave them all safe viewing glasses, and here's a kid just really smiling and enjoying looking at the sun yesterday.
I know, we've been so enthusiastically received by the local people here, and it's been such a privilege to be able to share what we know. One of the local women actually said that during a previous eclipse, they didn't know it was going to happen. So they actually gathered their friends and families and they went indoors to hide from the eclipse because they didn't know what was happening. So it's so great this time that we've been able to share with them what's going on, and they're all out here on the runway with us today to experience this.
Yeah, in fact, hopefully we have a little hole here in the clouds and we can go to the white light camera when it comes out. Okay. And, well,
so I guess we do have clouds. It's sort of peeping in and out. So it's a little dark right now. We were getting some good peeps there for a minute, but they've kind of disappeared now. So Paul, I have to say the last few days we've been spending a lot of time with Bill and the telescopes, checking out the sun, seeing what's going on, and it leads me to ask you, what is the sun again?
So the sun is a star, and at the core, the pressure and temperature bring together hydrogens, convert them into heliums with a loss of mass, which turns into energy, which comes out from the center, the core, out to the outer layers of the sun where the light leaps free into space from a layer called the photosphere. That's the part of the sun that we see.
Right. Okay, so we want to talk a little bit about the layers of sun that we're going to see today. So the first layer, the one that we kind of see with our naked eye if we were to glance at the sun, which you should never do, is the photosphere. So let's take a look at that. I think we're getting a little clarity here. So this is this a white light image that we're seeing?
This looks like a hydrogen alpha.
Oh, there we go.
There we go. Yeah, so
there we are. We see a few sunspots. Is that true on the sun?
Those may be filaments, but they may be sunspots.
Okay, fair enough. So what we're seeing...
They're filaments. They're filaments. This is a hydrogen alpha filter we're seeing, and there's a prominence on the top there. Okay,
so the hydrogen alpha filter is showing us a certain layer of the sun.
Right, above the photosphere, there's a layer called the chromosphere. And you'll see that during totality as a little thin pink to red layer around the edge of the moon on the sun part of the time.
Right, and one of the things I love about the photosphere is it's so active. There's a lot of activity happening there, including we sometimes see little prominences on the edge of the sun. I'm not sure if we're seeing any today.
Oh yeah,
Let's take a look.
Let's take a look. So here we have the photosphere view. It's oh no, that's still the hydrogen alpha.
Okay, we're taking a look at the hydrogen alpha thing.
With the clouds coming in and out, we have to adjust the gain on the telescopes all the time. So it's a dynamic process. Oh, but there is a wonderful prominence that really shows up in that hydrogen alpha filter.
Holy smoke, there is a giant prominence right at the top of your image of the sun. It's going out a little in and out because of the clouds, but that's absolutely gorgeous, Paul. So what's going on there?
Well, the sun is really rich in magnetic fields. Not only an overall magnetic field, but there are magnetic fields that twist up and penetrate through the surface, making sunspots and guiding in a dance the charged particles that make up the sun. So the charged particles move along the magnetic field lines, and as they move, they change the magnetic field lines. This is an amazing dance, and the result is charged particles from the sun reaching out into space, going out from the photosphere, through the chromosphere, out into the corona, the next layer of the sun. And that prominence is quite a bit larger than the Earth.
Yeah, that's incredible. In fact, I'm not sure I've ever seen a prominence that large before. It is really, really incredibly beautiful. So I think that we actually have an animation that shows, I hate to break away from this, but it shows some of the active activity from one of the satellites. We can see a lot of detail. So let's run that really quick.
So we have a satellite view of the sun. The sun takes about an Earth month to rotate once, so this is quite a bit sped up. And it just reminds us that sunspots are magnetic storms on the sun. Whenever you see a sunspot, think magnetic fields coming out of that sunspot, going back down into the sun.
And it is pretty incredible, again, to see the sun like this. We haven't seen this yet. It's very active, as you were saying. It's moving around these magnetic fields in a giant ball. That's absolutely gorgeous.
Oh, and look at the amount of the sun that's covered by the moon now. The eclipse is really progressing, and it's getting quite dim here.
It is getting quite dim here. So during the eclipse, we've talked a little bit about the photosphere, which is the part that you kind of would see with your eye if you were to look at it. And then we talked about the next layer out, which is the chromosphere that sometimes appears pinks, where sort of we think of those prominences living, but they reach out into the outermost atmosphere of the sun that we call the corona. So why don't you tell me a little bit about the corona?
So the corona is the sun's outer atmosphere. The gas in the corona is millions of degrees, and it glows with this dim white glow. The corona is one thing you can see with your naked eye when the photosphere is blocked by a total solar eclipse. So it's it's the great treat of totality, is to see that corona as a white series of lines guided by magnetism out into space.
Yep, and the corona today, we actually have no idea what it's going to look like, right? It's going to be a surprise to us.
Well, you know, scientists have predicted that there'll be like 4 lobes of the corona, so we're going to check our actual view of the corona with the prediction.
Right, but like the other parts of the sun, it's magnetic, and it reacts to this magnetism, so it's moving and changing, so it might not be a correct prediction.
We'll find out. You know, scientists, you stake your reputation on your predictions, and then you test them.
Okay, so while we're waiting, let's take a look at the sun. We're again seeing this, I believe that's the H alpha view, and that beautiful prominence. You can see how large it is. Paul, could you take a stab at exactly how big that is?
I'd say that's at least 5 Earth diameters on the bright part, and the dimmer parts reach out beyond 10 Earth diameters.
Great. So actually, while this image is great, we have another image that was taken from a satellite, so we can see a prominence a little bit closer up.
Yeah, the clouds are about to obliterate our actual view. So let's take a look at a prominence from the past. And you can see that reaching way out from the sun.
That's right. So that's in the upper, sort of upper right of this image.
Right.
You see a giant prominence.
And those prominences are alive. They're in action, with the magnetic fields of the sun guiding those charged particles out and sometimes back in to the sun. And there's the Earth to scale.
Right, so here you can see exactly how large those prominences. They're gigantic and very beautiful.
They are. I just love that one. It's so much in motion. So, in fact, those prominences can sometimes break free of the sun, as we're going to show you here, as coronal mass ejections, which were also sketched in the 1800s during a total solar eclipse. And so if you look at this, NASA satellite images of the sun, you can see giant clouds of ionized gas blasting out from the sun into space. As they continue out, those blasts can actually hit the Earth.
Oh, I see what you're saying. So these gigantic explosions on the sun are blasting particles at us, and those impact the Earth. And that makes me think that that's the hidden connection between the sun and the Earth I was talking about before, which means it's time for us to bring out Troy Klein from NASA. He's an education technology specialist. Great to have you here, Troy.
Thank you so much. It's a pleasure to be here.
Okay, let's check into the telescopes. I think we have a minute here, a little break in the cloud, so let's take a look at it.
Wow. Could you fix it and get us the actual feed? Well, Troy, what do you do at NASA?
I have a couple different jobs there. I'm an education technology specialist, and I'm also the education and public outreach lead for a mission that's called the Magnetospheric Multi-Scale, or MMS mission. I'm the mission education lead for them.
And how does that help us understand the sun?
Well, you know, NASA has quite a fleet of satellites right now that are up looking at the sun and the Earth and something that we call solar storms and space weather, because it's very important to us to know how to live with this star, our sun. And as you've been talking about just earlier, our sun is a magnet. It's basically a giant magnetic force, and it has an equator that's moving quicker than the north and south poles can keep up. And because of that, those magnetic field lines get twisted and tangled, and sometimes will create concentration of magnetic force. Now, what we're going to see in just a moment is there's that's where the spot. How that magnetic sun also interacts with our magnetic Earth. I have a great video if you'd like to see it.
Let's show that. Looks like aurora to me.
Oh, it sure does. Have you seen an aurora, Paul?
I have seen many.
It's the visual evidence that something is going on that started on the sun. And we're seeing some magnetic field lines right now that are coming out of two areas that look like sunspots. And when those magnetic field lines build up so much force, you'll notice that they start to stretch away from the sun, and something very important begins to happen that is actually the trigger of our space weather events. Now, as those field lines start to stretch and touch, boom, they connect and disconnect, and it expels a tremendous amount of energy and plasma and ions away from the sun in various directions. Now, the only time we're really worried about that, of course, is if it's headed towards Earth or where we have humans in space, and that can be very critical. Now, we're looking at this plasma. It takes usually about 3 or 4 days for the main effects of this to hit us, but the Earth is just amazing, and it's designed beautifully. It has an invisible magnetic force field that surrounds the entire planet. Now, you'll notice as these magnetic field lines of the sun come in, you'll be able to see them connect and disconnect with the Earth's magnetic field. And it doesn't stop there. Those field lines, the sun's field lines, actually pull the Earth's field lines behind the Earth as the Earth continues to regenerate field lines in front. And in the back, in the magnetotail, there was another reconnection event that just happened, which forced energy out of the tail of the sun, or the Earth, and also into the North and South Pole. And Paul, what happens when you put a lot of energy into the North and South Pole?
The atmosphere glows as an aurora.
It glows as an aurora, which is really, really amazing.
This is quite beautiful, and I think they're going to run some image from the ground, how this actually looks. There we go.
There we go. I had the opportunity with our team to go to Barrow, Alaska, and watch first light when the sun first appeared just for a moment over the horizon. And each night we would run out and see these beautiful green aurora.
Okay, hey, the sun just peeked out of a hole in the clouds.
Awesome.
Let's go ahead and take a look at that partial eclipse. Boy, it is really getting to be a narrow arc of the sun right now.
It sure is.
And we can see those filaments on the surface of the sun and hydrogen alpha, and the sun coming up.
With my solar glasses, I was able to see, it looks just like a little sliver right now to the human eye.
Excellent. Most excellent.
Oh,
Yeah.
exciting. I can also notice the lighting is starting to go down dramatically here around us.
That's right. Definitely. The sun is mostly blocked. It's getting cool.
It is.
It's
It
much
is.
cooler here.
That's really amazing. I
Okay.
have chills.
Yay. Well, I understand that the MMS mission has a real goal to help us live on Earth.
It really does. We're really concerned about societal impacts and how we live here on Earth, and how the magnetic energy that we have and all of these solar storms impact us in space and on the ground, with potential blackouts and even damage to satellites. So NASA is very invested with people and partners around the world to be able to launch satellites into space that study solar weather and space weather. I have a video with me of an amazing mission called the Magnetospheric Multiscale mission that actually, it's almost the anniversary of their launch, and they launched on March 12th last year. Here in this animation that we're looking at, Paul, we can start that. You'll be able to see something called an Atlas V rocket. Now, what was really cool about being at this launch is we invited students from Texas and from West Virginia and all over the United States to be part of this launch. These students in West Virginia actually built a life-size model of their own that we have on display. In this animation now, you'll notice Florida way in the distance on Earth, and in just a moment, the nose cone has all 4 satellites. They're 11 feet wide, 4 feet high, 26 instruments aboard each satellite with booms that go out and antennas. And some of these antennas actually stretch out to 160 feet apiece. And you'll notice there's a minor charge between the satellites as they reach orbit or towards orbit, and then they're able to separate and start forming something that is like a tetrahedral formation. And I actually brought something, Paul, that I'll be able to show you that students can actually do and download in their classroom in just a moment. Now, take a look at how beautiful these satellites are. These satellites will actually move around, and they're searching for magnetic reconnection regions that are around the Earth, because we can reach the Earth's magnetosphere, and we treat it like a laboratory. Now, as they go around and find a magnetic reconnection event, they will fly around in formation, and they have over 26 instruments aboard each one that will all snap at the same time. There are no cameras, but we get 3-dimensional data. That's why we have to have 4 satellites.
Yeah, that's really quite a formation with those giant antennas, and I'm glad you brought your visualization with us.
This is one of them.
On that magnetic field reconnection events around the Earth, I understand that it can really impact power lines.
It sure can. It sure can. And in 1989, for instance, there was a large power outage in Canada and northeastern United States that lasted several days, and it was pretty intense. Now, if you'd like to take a look at my visual, this is the representation. If this is a magnetic reconnection event,
yes,
my hand, these satellites are flying really fast, and they boom, right as that reconnection event happens and energy is released, they snap all of their instruments, and then the satellites keep on moving on in formation. So it's quite a nice visualization for the classroom.
That sounds really excellent. And what is this another tool you have here?
Yeah, this is basically, we're also experimenting with virtual reality. So we will have files online very soon for you to go and look at the satellite in space with, you can use Google Glass, you can use Oculus. There's several different ways to be able to do this. And it's just amazing. It gives you a sense of presence of actually being in space, or even on Mars or other planets if you choose.
That's really fantastic. I'm looking forward to that. We still have clouds overhead, but I'm looking to where the clouds are coming from, and there's a big blue patch coming on here.
I'm excited.
And that gives me a great hope for clear skies in totality. In fact, here's the sun coming through a quick hole right now.
Oh, that's beautiful.
We can go to telescopes here, and that wonderful arch of the sun and that prominence.
Oh, look at, yes, isn't that beautiful?
Yeah.
It's like the sun decided to show off for us a little bit today, didn't it?
It's great to be able to have it pop through those holes in the clouds so we can see it. There's a cloud eclipse again.
You know what, Paul? When I look on the horizon, we have clear skies coming in just about 30 minutes or 30 seconds.
I think we got some really good clear skies coming.
We have some great viewing opportunity.
Yeah. Well, let's go back to telescopes for a minute. There's a quick gap there. Oh, thank you, Troy Klein.
You are so welcome with all my toys and gadgets.
Yeah, thanks so much for sharing all that with us.
And hi to all of our students around the world with the MMS mission. It's exciting.
Yep. I
Thank
think
you.
now we just want to get ready for totality.
think
It's
we
getting
do.
close. People are excited. Do you see how dark it is?
Yeah, it's really dark.
It's really dark and it's so cool. We've been sweating for
Yeah.
days in the heat here, but it's noticeably cooler. There's a nice breeze. I think the drop in temperature is having something to do with the dissipation of the clouds over our head. I think you mentioned it, but just in case you didn't, we're seeing a big, huge blue patch behind the sun. I'm not worried about totality. I'm sure we're gonna be able to have a great experience of it. Why don't we just keep looking at the telescopes though for a little while?
Now that it's clear. Yeah.
Now that it's clear, let's let everybody get a good view of this small crescent with that huge prominence. It's absolutely gorgeous. I would say here on Woolly Eye, as it dims, we've got probably, I don't know, 250 people standing around us. It's mostly the Woollyans. A lot of the people from the high school are here. We're seeing a lot of students. We have the crew of the Solitude 1 here. We're getting a lot of cheers from the
Yeah,
scratch
that's
size.
great. Yeah. The kids are watching a video monitor, seeing what you're seeing out there in the world, and we just hear these yells and cheering going on whenever something really cool shows up.
Yeah, and also every time the clouds show up, there's sort of a boo,
Quiet.
and then as soon as the sun reappears, we get a big cheer. So what I'm seeing now over our head is just a few wispy clouds remaining in the sky. I think we're going to be good. There's a small patch, maybe 10 minutes, but it's very wispy.
Yeah.
And I think the temperature change again might dissipate that. So we're looking really good. We're now about 10 minutes, is that right, from totality?
Yeah, it's about 10 minutes from totality.
Okay.
So it's looking good.
So why don't we talk a little bit, since we have some time right now, about what it is that's going to happen in totality. We keep mentioning it, but we haven't actually talked about it directly.
Yeah, so as this crescent gets smaller and smaller, thinner and thinner, it'll get shorter and shorter until just one little bit of the photosphere is left uncovered by the moon. And that will lead to a phenomena called the diamond ring, with a bright spot like the diamond and a gentle ring of light around the moon.
That's right. And so we have an image of that. Now, this isn't right now.
No.
This image was taken a couple years ago, but it does show the diamond ring. It's going to happen quickly. It's only going to last for, what do you think, 15 seconds?
Oh, much shorter, just a few seconds.
And so we'll have that moment of the diamond ring, and we'll probably get excited. We'll probably be yelling, diamond ring, diamond ring, diamond ring. And then the next thing we'll see is called Bailey's beads.
Bailey's beads. And so the moon is not a smooth sphere. It has canyons and mountains on the edge of the moon, and the photosphere light can leak through those canyons and give us things called Bailey's beads. And so we'll also call out Bailey's beads if they occur.
If they occur.
It's different. The edge of the moon is different at every eclipse, so it'll be a unique expression. And when the Bailey's beads comes out, and you're looking through your glasses, when the Bailey's beads disappear, you see nothing through your safe viewing glasses. That's when you take off your glasses and look at totality.
That's right. I think that's something, again, people don't realize is actually when the disk of the sun is completely covered by the moon, you can actually look at the sun with your naked eyeballs. But I want to backtrack just a minute about Bailey's beads. And
Yes.
if we see them, we'll yell it out. But I just want to, what you're telling me is that there's little valleys and little divots on the edge of the moon,
Right.
and that the light will leak through them, and we can see that?
That's right. The light just shines through that gash on the edge of the moon, and you see the photosphere that makes these beautiful Bailey's beads. And then, when we get to totality, this is just an image. This is not live right now.
Again, this was recorded a couple years ago.
We'll get to see the corona of the sun, this white light reaching out from a black disk, which is the moon blocking the photosphere of the sun. And the corona was discovered during a total solar eclipse, the first drawings
Yeah.
of the corona. And in the corona, as you see it, there will be lines, perhaps, the lines of the solar magnetic field, reminding us the sun is a magnetic body.
That's right, and it's not even going to look like this. Hopefully it'll look really different.
Right. That's right. Well, we'll see. That's one of the great joys of every solar eclipse looks different.
Yep. And,
That's why we have to go to them.
and I just want to point out, you're really fading from my view.
It's really beginning to get dark, and the shadows are quite strange on the ground.
Right, I'm actually not seeing many shadows. They've kind of disappeared. Things feel a little bit a little weird. It's like twilight, but not really.
Yeah, definitely twilight. And sometimes the evening animals, the birds, start to sing in the forest during this darkening time. So we'll listen in to hear what we hear. Mostly I hear people being very excited by the sun being such a thin arc of light.
Yeah, it's true. We did ask the high school students when we were out at the schools if there was a lot of night song from the local birds, and they said that there was. So it's something we should listen for. I'm not sure we can hear it here on the runway, but we do expect animals to go into their nighttime behaviors. They definitely interpret this as twilight.
They do.
So we're experiencing that last little wisp of clouds. I'm not sure they're going to show up on the telescopes at all, but after these few little wispies, there's absolutely clear skies. So we're going to experience a fantastic totality. Again, we're seeing that crescent get thinner and thinner. We still have, believe it or not, a full 5 minutes to go. So there's still some time. Oh, look at that image. It's just absolutely beautiful.
Oh, that's a nice one. I really like the sun. And now, if people are looking, they can see it directly with the safe viewing glasses. You can use safe projection techniques to project that crescent on the ground. If you're under trees and you look at the ground, oh, listen to the yell.
We're getting a lot of this. I think that the local people are anticipating that we're closer to totality than we are. It is. It's so noticeably dark. The temperature has gotten so much cooler. We're getting a strong breeze. And so I think that this is all in anticipation of totality. This is definitely an exciting thing.
Yes, I'm getting chills. It's not just because it's getting cold.
It is. And the local community here is certainly giving it 3 cheers. Excitement is mounting. We are getting, it's dark in the crowd. There's a lot of yelling and merriment, a lot of excitement with my safe viewing glass shouting, very. When I look up, I am just seeing the smallest, tiniest of orange crescents. So we're going to sit for a few more minutes, continue to watch.
If they're this excited by
I know, I can't wait
arc of the sun, wait till they see totality.
I'm having a hard time being patient. I want to speed up the sun. The shadow is moving across this pole at 1,000 miles an hour.
That's
We're
right.
getting very near the darkest part of the shadow. I see that the crescent is starting to shorten. We're getting very close. Very, very close. I'm sure people at home can hear the crowds and excitement here. We're anticipating a diamond ring.
Oh, a tiny little sliver. Oh, it's really getting dark.
Here we go.
Here comes the
Very
shadow.
close.
Diamond ring! There it is.
Diamond
it's
ring effect.
great.
Oh my goodness. That is the most beautiful thing I've ever seen. Now we see the streamers.
Oh!
They're reaching out into the sky.
The corona is so nice. Look at the lines.
Notice we're getting a really strong streamer on the lower left-hand side.
Oh, wow.
It's absolutely gorgeous. I'm seeing stars. I believe I see Regulus.
Oh, yeah. So that's Venus and Mercury.
Venus and Mercury. We're not seeing other stars right now, but we are seeing Venus and Mercury.
Yeah, the sky has gone dark. It's like night coming on. And the clouds around the horizon are dimly lit with yellowish brown. It's the sunlight's still hitting the distant clouds. Oh, it's dark here.
I see birds flying overhead. Actually, a lot of birds have come out of the trees and they're circling.
Oh, and that prominence sticking up into the corona.
That's unbelievable.
Is just gorgeous. What a great set of cameras.
Absolutely gorgeous. If I put on my eclipse glasses, I cannot see a thing. We're all looking with our naked eyes.
That's a prominence.
So people in the crowd are asking us what the red prominence is.
They have good eyes.
They have very good eyes. Again, it's cool. It's the coolest it's been since we've been here.
Oh, this is just
Everyone has
amazing.
stood up and gathered around. The hundreds of people were sitting, relaxing in the shade. They're all now standing up in giant clumps. There's a lot of kids running around.
It was really great to prepare the kids yesterday to tell them, take off the glasses during totality, and I think they did from that giant cheer that went up.
Yeah, I know, Paul, when I'm standing here, it's so beautiful. It's so amazing. As I'm standing here in the shadow of the moon, it's so nice, and I feel so privileged to be able to bring this to the hundreds of thousands of people who are watching us online and at different science museums. And I just want to do a few shout-outs. I know they're watching this at the Singapore Science Center, at the Casa de Chihuahua in Mexico. They're tuned in at the New York Hall of Science in New York, of course, and at the Griffith Observatory in Los Angeles. And I also want to mention a very special viewing party near the Rose Garden in San Jose, California. So the crowd is sort of quiet. I think they might be a little odd. I know I am.
It's amazing. And my eyes are adapting to the dark, so I'm seeing more and more detail in the corona.
I can actually see the pink prominence.
Yeah, and the corona is reaching out more than 1 solar diameter. And in particular, I think there's a helmet streamer. It's like a World War I helmet.
Right, so we call that helmet, they're sort of long and pointed.
That's right.
It really stands out. And again, Venus and Mercury are incredibly bright in the sky.
They are showing up. I'm looking around. I don't see any other bright stars at the moment. But of course, the stars that are in the sky now would be the stars that were in the night sky 6 months ago, because we're looking at the daylight sky, not the nighttime sky. Oh.
Okay, so everyone's cheering. We're getting a lot of detail in the corona. It's absolutely gorgeous. You know, Paul, I also want to thank NASA and the National Science Foundation for really making this possible.
Got to remind people, the National Science Foundation also supports astronomy and astronomical sciences and education.
That's right. They have some ground-based observatories, including the National Solar Observatory.
Oh, here comes the diamond ring.
Okay.
Diamond ring.
People need to put their glasses on.
Time to put your glasses on.
Glasses? Glasses? Okay, the light is coming back. My goodness, that's so fast. All of a sudden, everything's lightening up just with that tiny, tiny bit of sun.
I can still see Venus. And here comes the arc of sun expanding. Oh, I'm so happy that the clouds completely cleared, as they often do.
So lucky,
during
Paul.
totality.
That was awesome. Absolutely incredible. Wow. Whew. That was truly amazing.
Oh boy, yeah. I was on the edge of my seat when those big clouds came by earlier. Oops.
Okay, so as the light returns,
Yeah.
I think what I'm going to do is I'm going to go over and I'm going to see if there's other people around, see what they thought of the eclipse.
Yeah.
So Troy.
Hey Robin, I am so excited. My heart is pounding right now. That was amazing. I couldn't believe how long totality was. And just before, we had all of those clouds, and it just completely cleared up and just made a beautiful sky. And then when I saw Exploratorium launch the drone into the sky to capture it, it made it even more exciting for everybody here.
Yep, but we'll hopefully have really good images from that drone that we can post online later. Our hope is to get a whole 360 of the view here.
Oh, that would just be incredible. We'll see if my video on my camera turned out too.
Okay, we'll check it out.
Thank you.
And we also have some local folks. Is anybody here want to talk? What did you think of the eclipse?
Oh, I'm sorry?
Did you enjoy the eclipse?
Yes, of
Did
course.
you think it was beautiful?
Yeah.
Yeah?
Mm.
Can you say it in the microphone?
Absolutely amazing.
It was.
Yeah,
It was really
yeah.
beautiful.
Beautiful.
Was it what you expected to see?
No.
No?
I didn't expect to see the stars, but I did see the stars.
Yeah. Yeah, excellent.
Can I talk? This is the live?
Sure.
Okay, I'm gonna say I'm gonna miss you, my daughter, and son in Hawaii, daughter in Pohnpei. I love you. I miss you. Okay, thank you.
Okay, great. Well, great. Relax. Enjoy what's happening today. We have over here, actually, coincidentally, we have the director of the Exploratorium, Rob Semper. Is there anything you want to say about the eclipse?
Hi, Robin. Well, it was an amazing experience. Heart failure with the clouds, but they parted at the very end, which is sort of a magic of the eclipse, the magic of Wolli Island. I've seen a couple eclipses, one in China in 2008, one in Turkey. This one was completely different. It was amazing because of the sunrise that you saw 360 around. The sky was not nearly as dark as it was in China, but it still had that magical piece of having looked like a hole was punched in the sky where the moon was covering the sun. It was just completely black, and then you saw the corona around it. And every time I see that, it just makes my heart sing to see that kind of experience. So really wild, really great to be here, and really glad to have the view without the clouds blocking it for us.
Great, Rob. Thank you so much. We have another local person here who's actually the principal of the high school, Alentino.
Hello.
What did you think of the eclipse?
I think it's amazing. I couldn't believe it. I couldn't believe that it's going to happen today in Wolli.
Yeah.
But this happening, amazing.
Amazing. And was it what you expected to see, or was it different?
Well, I was not really expecting to see something that would get darker than this.
Yeah.
But and if I have my pillow, I'll just lay down and start sleeping. It's already nighttime.
Yep. Well, the sun's slowly returning. I was wondering, Alentino, is there anything you want to talk or to say about Wolli and your experience of living here?
Well, I think Wolli is a really good place to stay, and you don't have to worry about money, as I would think, but life here is simple. Everything is simple. You just live it each day, one at a time.
Yeah. Well, we want to thank you so much. You've been an incredible host. And you, actually, yourself, it's been Alentino who's been driving us back and forth from the beach here. He's unloaded our gear. He's been looking out for our gear at night. He's been covering when it's raining. He's really done a lot of tremendous work to make this program a success. Thank you so much, Alentino.
Thank you very much.
Okay, so we're walking around. There's so many people here. I would say in general they're a little bit shy. On the Exploratorium, the cheers that you hear as the Exploratorium is again flying our drone to try to capture some video image. So Paul, we also have with us now Dr. Eric Christian. He's a NASA mission scientist. So Eric, what did you think of the eclipse?
Wow, this was really fantastic. This is only the second total solar eclipse that I've seen. It was very different from the one that we saw together in China, but just absolutely, the clouds cleared up 10 minutes before the eclipse. It was wonderful. The reaction of people was fantastic.
Well, you know, there was a prediction you showed me earlier today of what the corona would look like. How did it appear to your eye compared to that prediction?
It's a little hard to tell because to your eye it was pretty bright close in, but I think they actually got it pretty close.
There were about 4 streamers, I think.
Yes, I thought so too.
So
yep.
pretty good. Score 1 for
That
science.
prediction's from scientists at Stanford.
Yay.
Give them credit for it. So.
Well, next year.
So we got a great chance to come here to Wolli to see this eclipse, but next year the entire United States is going to get a chance to see, if not a total solar eclipse, a partial solar eclipse. It's going to be fantastic. NASA's been planning for over a year, and a lot of organizations are involved, and this is going to be wonderful, the entire United States. Why don't we roll the animation? So this animation shows both the penumbra, the shaded area, which is the partial solar eclipse, and the little tiny dot is the tiny area, 100-mile wide, that's totality. And you can see it comes from the Pacific Ocean, enters the United States at Oregon, goes right across the heart of the United States, and exits in South Carolina. So the entire country can drive to a place that's got a total solar eclipse. And even if you don't, the partial is going to be so good that it's going to be worth seeing.
The partial will be visible from all places in the lower 48.
Alaska to Hawaii, actually, and Florida to Maine. Yep.
Wow, that's going to be great. I hope people take advantage of it. This was such an amazing experience today. You must see a total solar eclipse sometime
Yeah,
in
if
your
you
life.
get a chance in your life, and this is one of your best ones. You don't have to travel far. It's going to be fantastic.
Well, let's look at this prediction for the eclipse next year in more detail.
Okay.
So what are we seeing here?
So here that shows a bunch of different rings showing different levels of partial eclipse. And there you can see the red line is the path of totality. And so the black dot is again the total solar eclipse, and you can see it goes right through Salem, Oregon, goes past a bunch of big cities, just misses Kansas City, just misses St. Louis, goes through Nashville, and then off the coast of Charleston in South Carolina. So just wonderful. There's lots of places you can travel to and get to see the solar eclipse.
That is just amazing. And so what'll it look like?
So this is a really neat animation that an amateur did for us. And what it shows is one snapshot of time when the total solar eclipse is right near St. Louis. And you can see how partial the sun is all the way from the west coast to the east coast. But this is just one snapshot. So the west coast has already had more partial eclipse earlier in the hour and a half that it'll take to go across the United States. And the east coast will have more coming up. So, but you can see that it's just fantastic for the entire country. It's going to be wonderful.
Well, I understand that next year you have a mission that you'll be involved with that we should know about.
So I'm currently building an instrument for a mission called Solar Probe Plus. NASA is going to launch Solar Probe Plus in 2018 to study the sun. It's going to be our first mission to the sun. It's going to go so close, 25 times closer to the Earth, to within 4 million miles of the surface of the sun. And the way we do that is we hide in the shadows. We've got this enormous heat shield in front of us, and most of the spacecraft hides behind that. The front of the heat shield is at like 1,800 degrees. The back end is sort of room temperature. And so we can have our instruments work and study the sun from that close, without being fried by this tremendous 625 times the area's sun that we're going to see.
Are you going to actually be inside the corona?
We're going to be inside the corona of the sun.
Thanks.
And one of the main questions that Solar Probe Plus is meant to answer is, you said earlier that the corona is hotter than the surface of the sun. That's really weird, because normally as you get further from a heat source, you get colder. Why do you get hotter? There's theories of why this happens, but we don't know. Solar Probe is going to be in the region where the corona is still heating, and we're going to be, for the first time, able to answer why the corona is so hot.
Well, I'm looking forward to finding out the answers. That's what scientists do.
It's going to be great. 2018 launch, wonderful.
So, and the mission, how long will it live?
It'll last for 7 years. It'll actually get closer and closer, using Venus to get in closer and closer to the sun. So the closest approaches aren't until late in the mission, but even the first go in will be closer than any other spacecraft there's ever been.
Well, thank you very much,
Thank you.
Dr. Christian. And now let's take a look back at the landscape around us. Lots of people.
It's wonderful.
Coming down from that high of totality.
Mm-hmm.
And now we can actually look up again and see that, it is quite arc of the sun visible.
Yes. Wow, it's coming back.
And it's so pleasant here with the sun partially covered.
Yeah, it's a lot better than being in the noonday sun on most days.
Okay, thank you very much, Dr.
Okay,
Klein.
great.
Oh, Dr. Christian.
Yeah, thank you. So I think we're going to go to the telescopes now?
Yeah. Off to the telescopes.
So we're taking a look at the telescopes now as the sun slowly returns. It's amazing how quick it churns from that very, very tiny crescent into a big fat one. It was interesting. I was just off camera talking with Stanley Redegrell, who's been helping us out here, and he just pointed out a couple, I thought, interesting facts. One thing he pointed out was that the birds are now doing their morning flight routines. There's been about a half a dozen birds circling the runway, and he said that's part of their normal morning routine, so they're very confused. The other thing he mentioned is that during totality, a lot of, and I heard it, there was actually some consistency in the chanting, and that the people here were doing one of their traditional chants that they do whenever they're surprised. So if a stranger shows up on the beach or if something unusual happens, their automatic reaction is to sort of make this, this chanting sound over and over, and it sort of spreads the word that's something going on. So I thought that was really, really nice.
That's just great. The things you learn as you travel the world to the locations of the total solar eclipses are amazing.
It is. It's been absolutely spectacular. And I know you and Eric were talking about the 2017 eclipse, which is coming up soon. And I just wanted to say to everyone, it's not too early to start planning for the total solar eclipse. And there's a few things that we think you might want to start doing right now. One is we sort of recommend that you go online and that you get a pair of these. They're called usually eclipse shades. You can just Google them. The ones that we got here are actually from a place called Rainbow Symphony, but there's other companies too, because you can actually look at the sun every day. You don't have to wait for an eclipse. And a lot of times you can actually see sunspots on the sun. So you can start tracking sunspots, getting to know the sun. So when really strange things happen, like what happened today, you'll be ready. There's another really awesome activity that we like to do. We do it all the time at the Exploratorium, where we create pinhole images to look at the sun. So we asked Troy to come back and to do a little demo for us. He's setting out his maps and getting ready. So he's prepping it. We actually had a local girl from Yap, Micronesia, who wove a special mat for this activity. So they're trying to get it all set up, get their white mat into place. It works better, the shadows on white. All right, Troy, what do you have for us?
Robin, I have a great way to show the eclipse if you don't have the glasses or if you just like to see it through very simple methods. One is just using a pinhole projector created by your fingers. I'll cross my fingers in a crosshatch fashion like this, and then just point it down, and you'll notice there are actually little eclipses appearing where the tiniest holes are, and you can use your focal length and adjust that until you can see the eclipses. I made a good one right there. The next way is we had a young lady here on Walleye who created a mat, just wove the mat, and if you hold it up at a certain angle, you'll see hundreds of eclipses appearing just everywhere on the sheet. Isn't that beautiful?
Yeah, it's a little hard to see on the camera, but it looks pretty good.
Yeah. And then another way is at NASA we're working with Eric Christian, and we're creating some pinhole projectors out of 3D printed material. And we've been experimenting with this just to see if we can make these appear in a good way that you can print them out as an STL file and then share them. The other idea we'd like to do with these is create a file online that you can place your monogram or any symbol that you would like inside this type of shape, download it, and then when the eclipse occurs, you'll be able to create a beautiful picture that you can do selfies and pics for all of us to see.
All right, Troy, thank you so much. So we only have a few minutes left, and I'd actually like to leave everybody with some images of the sun. But before I do that, of course, we'd like to thank NASA and the National Science Foundation for making this entire broadcast possible. And we'd also like to sort of give a shout out to the folks back at the Exploratorium. Thanks so much to the home team.
Yay, Exploratorium!
Thanks for all of your help and support. So with that, we're just going to leave you with some beautiful views of the receding moon.
As it moves away, restoring the sun to us, saved once again by the laws of celestial mechanics.